Okay, this is our ready for the 7-1 to 7-4 quiz. We're going to do cross products. I don't know that I set any up with you guys or not. Do you have anything written on these problems yet in that packet? I swore we started some of them. I know I did in my other classes, but we need to do cross products or equals. So we're doing 6 times p minus 4 equals 2 times 5. That's 6p minus 24 equals 10. Add 24 to both sides. We get 6 times p is 34. And then when we divide by 6, we're going to get a decimal. Now on your calculator, you're going to see 5.6666. It's going to be a bunch of sixes. And then at the end, it says a 7. Well, that's because when your calculator runs out of room to keep writing sixes, it rounds up the last one. So it is a repeating 6 forever. To write that, you can write 5.6 and then put a bar over the 6 to mean the decimal repeats. Or you might want to know that that's 5 2/3. Okay, number 10, which I'm sorry, I don't know why these started with 9 and 10, but I put it in order for the sections. I'm going to go ahead and distribute right away. That's 7k minus 42 is equal to 54. 6 times 9. Add 42 to both sides, and we'll get 7 times k is 96. And then we'll divide by 7, and that's not going to come out beautifully either. What is it? 13.71 or something like that? All right. It doesn't repeat. All right, so that's that. You should be able to obviously do some cross products or equal to the algebra. Don't assume things are going to come out nice all the time. They don't. Okay, how can I set up number 11? And I had thought we already did. All right, Darylyn. X plus 3 over 3 equals 15. I'm just color coding over 5. That's fine. Perfect. It's not the only way to set it up because there are 5 ways to set it up correctly. If somebody did x plus 3 over 15 equals 3 over 5, that would work also. Okay? As long as you have 5 across from the x plus 3, there are 4 ways to correctly write the proportion. 5 times x plus 3 would be 5x plus 15, and that would equal 45 by doing your cross products. Okay, then I'm going to subtract 15 from both sides, giving me 5 times x is 30. Divide by 5, and I get x is 6. Okay, I'd like someone to help me set up number 12, and I'd like different people to answer today. And if you don't raise your hand, I will eventually probably call on you. Okay. All right. Oh, thank you, Cadence. 25 is to 20. Okay. $35 is to, where are you getting a 28? I got to solve for x, right? There you go. Got it. Maybe you already solved it? Okay. So that's okay. 25 times 2x plus 4 would be 50x plus 100. And then 20 times 35 is 700. And then subtract 100. 50x is 600. And then divide by 50. What did you have? It should be 12. Oh, I know what you did. You plugged 12 back in. Didn't you? Well, good job. Yeah, if you wanted to know what the length of that side, it would be 28. All we needed to do is find x. Or did you maybe try to figure out what would make the proportion true? It does? And I'm missing that? Actually, really? Okay, sorry. Let me not forget that then. Also find the scale factor. Okay, the scale factor, and that's important too, because you're going to need to be able to write the scale factor on your quiz tomorrow. 25 to 20, and you could reduce that would be 5 to 4. 5 over 4. Now I should have written the scale factor for this one is 15 to 5 or 15 over 5, which is divide by 5, you get 3 to 1. Okay, I don't know why I don't have the directions correct on here. All right, number, oops, that's just a repeat. I guess we did this together, didn't we? Did we set this up? All right, so we had already done this. Reminder, if you're going to show or just you try to prove that some triangles are similar, you need to compare. Over here, what I did was do short side to short side, and then I had to realize that it would have been long side to long side, 33 to 35. All right, and then this one was by angle, similar. The triangles were similar. And this one was side angle, side similar. Okay, and I had found out the congruent statement or similarity statement, not congruence. BCD was similar to BQR. All right, let's try, and I think we jumped around and set up certain ones. We're going to go back and make sure we have the answers to all of them. I would like someone to set this one up, and I want you to be a little bit careful. Well, you need to be careful about what you do. There's one step you need to do before you set this one up. Okay, I was trying to get someone different to answer. All right, Kenny? Okay, so you subtracted from 21, you subtracted 15 first. And you said do x plus 3, because you like to start with the x, all right, over 6 equals 20 over 15. Now, that's certainly one of the 4 ways to do it. But you do need to subtract the 15 and get that that's 6, because you want to compare this to this. And you want to compare that to that. So if you like going like upside, you know, like look at the fractions, right? You can do 15 over 6 equals 20 over x plus 3. Now, explain why. Well, look, you still have 15 across from x plus 3 and 6 across from 20. You're going to get the same results as this proportion, which is a fine proportion. So regardless of which way you set it up, if you do it correctly and have the right things across from one another, there's 4 possible ways to write it. So 6 is going to give me 15x plus 45 equals 120, regardless of how you set it up. And if you're not getting that, then you set it up incorrectly. So I've got 15 times x equals 75, and then we are dividing by 15, and we should be getting x is 5. Apparently, I set this one up before we left last week on Thursday. X plus 11 is to 15, is 14 is to 10. Let's go ahead and get the answer. Distributing, you get 10x plus 110. What's 15 times 14? 25 minus 210. Okay, and then subtract 110. Got 10 times x is 100 then, and then we'll find out, divide by 10, and we get x is 10. You probably could do that in your head. All right, I believe you got to switch to a page or flip pages. And I got to go find it because I had this out of order. This is the one that says 7.3 to 7.4 now, I think. Right here. Okay, to review another thing that we've learned. It states if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. Okay, well, you can't just say, well, they look like it. That doesn't work. So we're going to have to show if they are by showing whether the sides are in the same ratio. So what I think you should do is say, well, 5 is the smaller number on the first triangle. What's the smaller one on the second? Yeah, the 13. So I need to check if 55 over 13 equals, now I got to compare the other two sides, 56 over 14. Now I need to reduce these fractions, and I don't know, this doesn't seem like it's reducible at all. This one does. These aren't equal, are they? If you type this in your calculator, 55 divided by 13, and then you hit your math enter button to reduce, nothing happens. If you get the same thing back, it just means it doesn't reduce. Now, you're going to get something that reduces for this one. 56 and 14, you could cut in half. Oh, actually, you could divide them by 7, couldn't you? Oh, geez, more than that. What's that reduce to? Pardon me? 4 over 1. So you're getting 4, which means 14 divides evenly into 56. So these aren't equal, so the triangles are not similar. That's what that tells you. So if you wrote a similarity statement, obviously you're going to get the question wrong. Okay, the next one, these triangles have parallel lines. Here we have the parallel lines, so you can consider the other sides, etc., as transversal. So we've got alternate interior angles congruent, and we got it going this way as well. So these are definitely similar. It says triangle LMN, that would be similar to triangle LSP. And it would be by angle, similar. Number 3, vertical angles are congruent. You can mark that on your diagram. Next, you would need to check if the sides are in the same ratio. So I'm going to compare 18, it's smaller of the numbers on the small triangle, 18 and 22, and of the other triangle, on the other triangle, which one's that compared to? This is real important because it's easy to mess up these. What side should I compare 18 to? What number? I heard 143, and it's not 143. 18 is smaller than 22. What's the smaller one over here? 117. All right, we have to see if 18 over 117 is equal to 22 over 143. Okay, I hope you're paying attention and that you understand why I'm comparing the numbers the way I am. Now I'm going to reduce these fractions. So grab your calculator, type 18 divided by 117. Practice makes better. It's not perfect. Math, enter. Practicing is helpful. 2/13. And then check on your calculator to see if 22 over 143 also gives you 2/13. And it does, right? All right, so since those are equal, that's the scale factor, 2 to 13. And that means that these triangles are similar. So we got triangle B. Oh, there's the B. So C to D, bless you, would be similar to BGF. Bless you. And then we would write by BGF. That would be by side, yes, angle and a side similar. Okay, angles are congruent, two sides are proportional, side angles, side similar. This should be SAS similar too if they're in fact similar. So I go again, 50 over 59. And the other pair that would compare would be 66 and 78. Are those equal? Oh, 50 over 59 does not reduce. 66 over 78 does, but it sure doesn't reduce to 50 over 59. What do you get? 33, oh, wait, I think they're both divisible by 6. So is that 11 over 13? And those aren't equal, so not similar. All right. The 32s are really hard to tell where they're meaning for those to be. I want to share with you that they're by S and V. Vertical angles are congruent. These triangles are automatically similar by angle, angle, similar. Let's see. V, it says WVU, so we have to do WST. Okay. On number 6, I'm going to compare all the sides. I can compare the 36 and the 98. That needs to equal what? Can someone tell me another fraction I should write? Should I write 48 over 84? Okay, we need to listen and focus for a moment. Look up. Come on. I just compared 36 to 98. If I start with 48, what's the bottom number need to be? Can't be 84, I'll tell you that. It's got to be a whole side, right? Don't make that mistake. It's really tempting to write 48 over 84 and 35 over 64. You can't. You've got to find out how long those sides are. So you have to add. That's 120, 32, isn't it? Okay, so 48 is to 132 as, I don't know why I messed with my colors there, as 35 is to, 99. These are not equal. I could reduce these guys, 18 over 49, and this one's going to be something weird. Does anybody reduce 48 over 132? 66, 8 over, it's 4/11ths. And then this one doesn't reduce at all. So these aren't equal. See, these are not similar. All right. We already went over, for whatever reason, 7 and 8, didn't we? I don't know how we picked and choose that day, but X is to 20 as 14 is to 35 for 7. All right, so since we did 7 and 8, let's jump to 9. Put an X on 9. Now, I want help setting this up, please. Okay, pardon? What? We did 7 and 8 the other day. Yes? Am I in the right place? Is everybody else okay? Your worksheet matching up? Did I mess? Hope I didn't give you one that's messed up. Okay. As long as you got everything, well, then I'm happy. All right, I needed help. I want someone to volunteer. If I don't get one pretty quick, I'm going to ask. All right, Evan. 56 over, okay, equals x over 65. You got it. Okay, all right, this is the long side. This is the long side. So x and 65 are corresponding, and 56 and 40 are. So that's set up correctly. It could be any way as long as you've got 40 times x, 40 across from the x. Excuse me, 56 times 65. I guess I'll grab my calculator. Should make Evan finish it for me. That's 3,640. And then you're going to get x is 91 when you divide. All right, 10. Who wants to tell me what to do for number 10, please? Kylie. 5 over 10, short to short, good. Equals x over 20, good, long to long. And again, you guys, if you started with the x, you just have these fractions flopped. 10x equals 100, x is 10. I keep trying to get rid of this page, and it just haunts me. There, I think it got left off now. Nathan. Number 11. Set it up, please. Dariana? Okay, hold 1 second. 26. Okay, now to you in the picture, which one would be longer in the top figure? Like, which one? The 26, would that be longer than the 2x plus 2 side? This looks shorter, doesn't it, than that? Okay, so let's do long to long. So which would be the longest one in this one? Yes. Okay, good. All right, so let's do 26 over 169 equals, and now we'll go over here to the short two sides. 2x plus 2 over 117. Yep, there we go. Do I? All right, is that better? Just, and kind of like think about it, if you turn this one, it would lay with that. This side would rotate to there to make a match. But the easiest way to do it is to think on here, which one's the shortest, and here, which one's the shortest, and then start with that, or vice versa. In each of them, which one's the longest, and start with that. It does. Okay. Welcome. All right, and then we need to finish this off. Oh my gosh, these numbers get big, don't they? 169 times 2, 338. X plus 338 equals 26 times 17. 30, 40, 2, like that. Okay, let you guys use your calculators. Subtract 338, and we're going to have 338x equals something. Okay, and then divide by 338, and it actually comes out nice, doesn't it? All right. Now I would like to get the next one set up. Let's see, I haven't called on quite a few people yet. Lexi, could you help me with that one? Okay. Now, wait, and 99 over 33. Now, double check a second. I'm a little, okay, down here, which ones, all right. Yeah, you got to go over the 33. Do you see why this one's longer than that one? And up here, this one's longer than that one. So we're going to want to do 31x minus 2 over 33. So there, and then we'll do the 99 then over the 27. Okay, so I appreciate it even when we don't get something the first time, but we want to understand it, and that's how we're learning, is to fix anything. So we're going to get some big numbers again. Yuck. You can do some reducing. Maybe some of you have noticed that you could maybe reduce this, and then your numbers wouldn't be so huge, but I'm just going with what's there. So what's 27 times 31? How much? Oh, gosh. I'll grab it because I couldn't hear you. 31 times 27? Okay. 837x minus 81 equals, and then I got to do 33 times 99. Right, like that? Okay. Then we're going to add 81. Glad we have a calculator. 837x equals 3,348. And then divide by 837. And it does come out nicely. 4. Okay, does everybody okay with how we are setting them up? So we want to be careful paying attention to which sides correspond. I know it can be tricky, especially when the sides aren't that different. Like the lengths aren't that dramatically different. All right, let's see what we got on the next one. For some reason we already did 14. I need a setup for 13 and pay attention to short to short, long to long. Emily, can you help me with that one? Okay. Yes, it would. Okay. Now, wait a minute. What's the matter, Olivia? Because you were wanting to be a trick one? I know. Okay, let's see why, though. Why is this one not tricky like that other one? All right. See how that is shorter than 121? Over here, this is shorter. Okay, that's why. So now, wait, I'll let you finish, Emily. What do you want me to write for the second fraction? Okay, 121 over 22. That's it. All right. Cross products. 5 times 22 is be 110, right? 110x plus 17 times 22. Someone calculate that for your teacher. What's that? 374. And then 14 times 21. All right. Subtract 374. I hope we're all agreeing with these numbers. Yeah, I'm going to get 1320. And then, that's going to divide nicely into it's 12, isn't it? Now, I had set up number 14 already. If you were wondering why we didn't use 65 and 104, you could have, but I just thought people would see it like that. All right, we had 7-4. Okay, we want to get through this, so I still want some help here. I've got parallel lines, and then these are like transversals through the parallel lines in a way. These are proportional parts then. So this is just 6 over x, you can go vertically, equals 4 over 6. Or you could have gone across. 6 over 4 equals x over 6. Either way, it's 4 times x equals 36, and x is going to be 9. Okay, so if I put an x on number 2, some students see it like this. You can even do it like, okay, I see this is a fraction. 3 over x, 12 over 20. That works. Okay, I can go that way if you want. Or you could say x is to 20 is 3 is to 12. Regardless, you have x across from 12. You get 12 times x equals 60. And you divide by 12, and you get x is 5. Okay, now, number 3 challenging, or a little bit. I'm going to put an X here. There's an easy way to do the problem, and there's a little bit trickier way to do the problem. And let me just say that if you want to use that 1, you have to have something written here, and you don't. Any ideas that someone wants to give me for what to do? All right, Cadence? Pardon me? Yes, what would you start to do? What did you do first? Where'd you get a 5? I don't see a 5. Oh, you did 6 minus 1 and put this is a very good idea. All right, so you did whole side to whole side, whole side to whole side, basically. All right, so he went 10 is to 5 as x is to 6, which would work. I think some students might see better 6 over 5 equals x over 10. Careful about that x being first, though. Regardless, this is the best way to do the problem. Cross multiply and then divide. So 6 divided by 5 would be 12. Now, there's a little bit trickier way to do it. What if you wanted to use that 1 and you didn't think about that 5? Someone would have maybe written here that this is x minus 10. You could still do the problem. So 1 is to x minus 10 as 6 is to x. I don't know. I think that is a lot harder, but it would give the same results. So forget about that. Do what we did. And number 4. What is the setup for number 4? Chloe? Do you want to start over there? 6 over 4, piece over piece to piece. Yep, we can do that. And that's because x and 4 correspond to the same piece along those parallel lines cut by the transversal. So 6 times x is 36, and we should be getting x is 6. Divide both sides by 6. All right, 5. I'm just curious how people set things up, so I'm just going to ask. Abby, which way would you set that one up? Okay, so you went 10 over 5, so you were coming from up here, and then you went down there, and then you went down there and came back up. You did write x over 3? Okay, great. I'm so glad, because you started at the top, you got to start at the top on the second fraction too. All right, so 10 over 5, x over 3. Great. You cannot, flip that over. All right. So as long as you've got that, you have 5x equals 30. What did you get for x? Yes. Okay, great. All right, and then, what about number 6? Tasha? Oh, I didn't mean to. How about you want to help me with that one? I sure can, but then what would I have to do on the other side? Be careful there. Can you do 2 over 3? What? Well, I agree with starting with the 2 because that does correspond to that, right? Yes, ma'am. 2 over 1. You have to subtract. So x over 2, 2 over 1. Do you see why now? Because that corresponds to this. So x over 2, 2 over 1. So this can be x is 4. Now, let me go back to what you started to say. When you started to say 2 over 3. All right, for a minute. If you did 2 over 3, it would need to be x over, then you'd have to have all of that, which would be x plus 2. okay? Because all this 3 is all of the distance there. X plus 2 would be all that distance. This is a way you'd have to do it if you use 2 over 3. This is a shorter way. All right? 7. Okay, set it up for me. Oh, Robert. That'll work. Okay, and I know a lot of you might have just done this. You see what I'm saying? Fraction, fraction. And that works too. You will still have 15 and 16 across from each other and 12 in the x plus 12. So regardless of which way you set it up, 12x plus 144 equals, I don't know, what's 15 times 16? 10? 240. That'd be, yeah, 225 plus 15, 240. Okay, and then subtract 144. 12 times x is 96. All right, and then get 8 by dividing by 12. Bless you. All right, setting up the next one. I think that it would be nice if you just use that fraction you kind of see right there. 2x plus 2 is to 4 as, but what would I have to do next? 4 over 2. Okay. All right, cross products. 4x plus 4 is 16. Subtract 4. 4x is 12. Divide by 4. And I know I'm going kind of fast. Want to make sure we have all of our answers here. And then we have all the answers to that packet now. Here's what I'd like to say about what's left. You still had a worksheet that said practice chapter 7, right? It's a single page worksheet. Okay, if you have that out. Oh, that is not it. I was thinking of posting it. See what it looks like. And I know we did a little bit off of it one day. Right here. Do you remember this one? This is the single sheet one. Okay. That's all we did was like 3 questions. I could send maybe a key to the Google Classroom. Okay. So you could check that one. And I'll post, maybe I'll even record and post that there too. Okay? Quiz tomorrow.